Welcome, everyone, and thank you for attending our webinar on 10 tips for responsible AI, how graphs add context. My name is Meryl Lee, and I'm part of the webinar team here at Neo4j, and I'm joined by Amy Hodler, Analytics and AI Program Manager. We're super excited to have you here with us today to talk about this important topic. A few housekeeping items before we get started. We invite you to submit any questions you have throughout the demo or throughout the presentation using the questions tab located at the top of the screen. We'll answer as many as we have time for at the end of the session. And if we don't get to all of them, someone from the Neo4j team will reach out to you directly. And I also wanted to point out that up in the handouts tab next to Q&A, there's a PDF you can download. And that has links to some of the resources that Amy will be referencing in her presentation. So feel free to download that. With that, I'll go ahead and hand it over to Amy.
Hi, everybody. Thank you for joining this morning or this afternoon, depending on where you're at. As Marilee said, I work on the AI and graph analytics area for Neo4j. And a little bit about me, here's how you can get a hold of me. I'm also really into network science in general and love research and writing, which is why I co-authored the book on graph algorithms that's available through O'Reilly. And I also love to bike. So if any of you can guess where I am in that picture, that'll be fun. So that's me in a nutshell. And one of the things that kind of led to this topic area about responsible AI and just looking into it is a colleague of mine who asked me to look into how graphs may assist with AI and AI standards in general. And so kind of a big a big kind of lofty statement is, how might we be able to help with, AI standards, kind of led to the thought of, how we can actually help with being more responsible about our AI. And what I noticed when I started to research, and you guys can do this as well, is there's a lot out there if you just look at the data, if you just look at what's available today and some of the issues. So of course, the first thing you do when you start to think about AI ethics responsibility is you Google, and you probably have done this and have seen some of these same stories. And I think they fall into three categories of AI not doing well. One is just biased AI. So the first example here on the page is a example from Amazon Recruiting, which they shut down their tool as soon as it was realized that this was happening. But it was providing some recommendation biased against women. And it basically looked at current resumes, current LinkedIn profiles, current profiles of employees, and trying to match, well, these are good employees, these employees work well for us, who is similar to that we should recommend. So classic training scenario and training issue. And on the upper left here, you can look at the male and female proportion of employees in technical roles for Apple, Facebook, Google, Microsoft. We don't have the Amazon numbers, but you can see just in technology in general that it skews more men in technical roles at major technology companies. And so you can imagine this AI is learning on what it sees and what currently exists. And it turns out that there are differences in the way women and men describe their accomplishments, the kind of hobbies they choose, and the AI was picking up on these differences and training to create an environment exactly like the environment they had. So that's an example of bias in AI based on training. The other one that's on this screen as well is recognition, in particular facial recognition. So the Gender Shades Project looked at three main softwares that are used for facial recognition, compared them, and said how do they do on men and women and how they do with people of different shades. You can see the numbers there that if you are a lighter skinned male, the accuracy rates are really quite amazing, 99 to 100% accuracy in the evaluation. If you're a darker skinned female, you could be down to 65% accuracy. And this is important because facial recognition isn't just used for games; it's used for accessing to buildings instead of your key card. It's used in policing as well, and so it has a lot of implication. And that's one of the reasons why last year Amazon actually spoke out in favor of having U.S. regulation of some sort on facial recognition technology. So 2 examples of trying to do the right thing, but because the data itself was skewed, that your AI becomes biased. Another area that isn't as prominently known, but this is the idea of unknowable software, unknowable AI. This example is a inmate, Victor Rodriguez, who actually had participated in an armed robbery when he was very young, was in the system for 10 years, had model behavior. He helped other inmates. He was expected, even by the parole board, to actually get parole because of his background and how he participated in various programs, but was denied because he had a high risk assessment from a piece of software called Compass. Now, this software is interesting in that there's over 100 different factors, weights, a lot of interdependencies that give you your score. And this score was also, it also varies by inmate. And they found some questions within it, and some of them subjective actually, that would have changed the score from an 8, a very high risk, 8 out of 10, down to a 1. So some of those questions, a little bit of, debate as to whether those are what caused his parole to be denied. What is really terrible to me is that when his lawyers requested to have the logic explained of those factors and those different elements that gave him his score, a judge denied their request because it was commercially proprietary. So whether we're talking about AI that is just so complex, or it's just unknowable, we don't understand how it makes a decision, or that perhaps it is protected for commercial reasons that we can't tell you what our logic is. This is another form of AI, in my mind, AI going bad because it's unknowable and we don't have the right to know. Victor Rodriguez was eventually allowed to have parole, but not on his first attempt. So he did get parole in a subsequent attempt. But we still don't know exactly why his assessment was so high in that first round. Another area that we think a lot about, or I think a lot about, is AI working absolutely properly, but not appropriately. An example for me of that is the Chinese social credit system, where it looks at citizens' behavior for both social and credit worthiness. And in the US, we don't usually put those two things together, but it will score things based on your financial habits, which you would expect for a credit worthiness score, but also social behavior. So in this picture, we have recognition and trying to do, it looks like in one case, maybe facial recognition of people walking, through the street. So it can, if you jaywalk in an area and you're captured with facial recognition doing that, that can affect your social credit worthiness. Same thing with smoking. If you smoke in an area that's a non-smoking area. So there's behavioral things that also go into this. And it's going to affect, by the end of this year, they estimate it to affect 1.4 billion people will be in the system by that time. Quite a few already in the system. But it affects not just their economic rights, but also social rights. So things like how fast internet you're allowed to get. In fact, expect your credit rating, which would impact, maybe if you're trying to buy a house or rent an apartment, but also, as I said, things like even, the speed of your internet and other areas as well. And so this is an example for me of it's working as designed, but in my opinion, not really an appropriate use for AI. And so these things together, the idea of bias in AI because of training, unknowable AI and what I would call inappropriate AI, reading these stories, doing that research is what led me to the idea that we need to be responsible about the way we implement AI. So I think any of us that either create, train, deploy AI systems, any kind of an intelligence system actually, that we have a duty to guide the development and the application that fit our social values. Now, that will change and vary depending on where your systems are implemented. But in the US, I believe that has a lot to do with, and I think a lot of us would feel accountability so that we can have not unknowable AI, that we actually have some accountability when things happen, that it's fair and operating to the way it was expected. So the intent of the AI system is actually, can be seen and applied in the outcome. And then in a way that the public can trust as well. And so the public can have trust that it's reliable and doing things in a respectful manner. So I think those things are important. And I hope most of you, thinking about this can agree that being responsible about our AI is something that we have to do. We can't say that it's hard and we're not going to do it. So working for a graph company, you can imagine why I see things through a lens of context, and having that love for network science, kind of understanding how context can help us do better. And I do believe that AI needs context in general to do well in all different areas, and it's understandable if we think about, as humans, we use context to make decisions. You think about the driving scenario. We're not just thinking about the lines in the road. We're thinking about the signs, the other cars that we saw go by, the drop in temperature that might indicate that it's going to be icy. The temperature changes, how many trucks, what time of day, what's raining. I mean, there's all these things that we use to contextualize the decisions that we make. And it's unfair to say AI doesn't need that context as well, or to not give it that context. And so not just raw data, but what's the context of that data coming in? And it's really required so that AI systems can learn from this information that's around them. They can make judgments and refine judgments as they change, so they can be flexible to a drop in temperature and the fact that you're approaching a bridge. Because bridges always freeze first, right? And then adjust to other circumstances around them, maybe traffic and things of that nature as well. And so AI requires that context too. And there's an example that always makes me chuckle. We saw her duck. Just sounds simple. If you were to see a picture, you would know exactly what that meant. But AI has a really tough time with this. If you can imagine, it could mean that you saw my pet waterfowl. Or possibly it means that somebody named Wee saw my rubber ducky. And maybe a little more morbidly, you've come over for dinner and duck is on the menu. So we've got to take care of getting the duck ready. So potentially very different interpretations. AI has a hard time with something like this. And without context, it has a tendency to be very narrowly focused. So it only understands a narrow aspect of what has been trained on, so not so flexible. Your predictions aren't optimal because they don't understand the context in which we're talking about this duck. And you have limited transparency thinking about that unknowable AI. If we don't have context, we don't know how the decision may have been influenced. So many different potential problems, and AI is often limited without context. And graphs have a fantastic way of adding context. And the reason for that is that graphs are context. They are built for relationships. They were originally invented to understand, and they use relationships to actually build out graphs. Graphs are nothing but a mathematical representation of a network, which is context. And so that's why they add value and they enrich data with more usefulness. And as we know, most of us, there's really no data that's completely isolated in nature. I've got one picture of a star here, but stars in and of themselves exist in context. And you can, if you think about that, a star in context gives us a constellation, and we can navigate by that. And if we're thinking about navigates, maps, adding in that context of what's next to what, how far, how long does it take me to get somewhere, what's the best route somewhere. And then if you add on more context, you get things like navigation systems. Okay, that's a lot of more context. But if we keep layering on, we even get whole new industries. I think about what Lyft is doing, the context of navigation, timing, who wants to share a ride versus have a ride on their own? What's the best route? And so graphs allow us to add context to what otherwise would be isolated data points. And every time you do that, you layer on more meaning and more usefulness to the data as well. And this is bread and butter for Neo4j. We actually invented the property graph model in 2002. The lore is that it was the back of a napkin that started it all. It's a very simple idea if you think about it. We've got nodes. Those are the nouns in our network or whatever we're trying to understand, employee, company, city. And you've got relationships. You've got pointers to things. So in relationships in Neo4j have direction. So the CEO has a start date, or the company, has a CEO that started on a particular date, and that's actually an employee. And these relationships and nodes can also have attributes. You can see the start date, name, employee ID, whatever that might be. And this really simple model is actually extremely flexible. It's what we use to add value, add that context so that we can then innovate on it. And we can do this with millions of data connections per second or billions of nodes if we're talking about analytics, tens of billions of nodes actually. And so the simple building block allows us to add context to whatever it is that we're trying to build or analyze. And it's not just in business that we're seeing graphs add context and graph accelerating innovation. And we're also seeing it in the AI world as well, and seeing it in the AI research world. This is just a simple illustration looking from 2010 to the end of, and actually creeping into to 2019, just the acceleration of graphs in AI research as well. And so that's, as you can see, we're looking at close to a fourfold increase, all kind of really kicking off sometime in 2016 as well. And so we're seeing it happen in the business world. We're seeing graphs actually enter in the AI world as well. And if we think about how graphs add context for responsible AI, I believe there's 4 ways, very substantial ways that are important. They focus around robustness of systems and trustworthiness of systems, but adding in that context to give us more accurate predictions. Accuracy is really important if we want to have a fair system. Flexibility. So if we think about flexing to different situations, that's important. We talked about driving, being able to flex to different scenarios is important as well. And graphs can add that by adding in more context. Fairness. So again, if we want to have a responsible system, we have to have a feeling that it's been based on information that's fair, that it represents how we're implementing it and the group that we're implementing it into. And then reliability on of the system, and explainability as well. If we can't rely on it, if we can't have any kind of explainability, it's hard to trust the system as well. So I have a couple examples to kind of help illustrate that. This one, very important example, just last year, they're estimating $100 billion in cost for the opioid crisis, and that's non-fraud cost. But even more important than that, just a couple years ago, they were estimating 47,000 people in the U.S. Died from opioid overdose as well. So a very critical problem. There are ways that we can employ machine learning and graphs to help combat some of this. There's a couple examples looking at fraud detection actually in opioids there, where you can use graphs to more accurately predict things that may be indicative of fraud in the opioid insurance, and thereby track down and try to cut down supply. There's an example on neo4j.com. If you go there and do a quick search on opioid, you'll find some work that a colleague of mine, Mark Quinlan, did, looking at prescriptions, the provider and prescriber, the pharmacy, the patient, and looking at these complicated relationships and trying to use various different algorithms, including community detection algorithms, to reveal these tight, unusual clusters of behavior. And then there's other research as well, using graph algorithms to look at multiple different communities, and then doing machine learning on top of that to try to predict what might be a inappropriate prescription as well. And so being able to be more accurate about what is and isn't appropriate for prescriptions can also help with just cutting down on those inappropriate opioids out there in the world as well. So just one example about predictive accuracy and graphs providing more accuracy in predictions. We see that over and over again because relationships, which is what graphs are about, are very predictive of behavior and currently and in the future. Another area that is of concern is manipulating data. And so it's not unusual that you would get criminals trying to misrepresent information. What is very scary to think about is sometimes they do that for quite some time in a way that we can't detect, so flying under the radar. We see that in fraud, and we also see that in cases like a recent U.S. attack on our a cyber attack on our U.S. Electrical grid system as well, where no damage was actually done, but manipulation of data was there, and infiltration of the data is there. And why that's important when we think about it from an AI standpoint, if we're thinking about reliability and explainability, if we can't prevent, or we can't be sure that the data that our AI is relying on hasn't been manipulated, it's going to be very difficult for people to trust the results and the monitoring. Imagine an electrical or a energy grid standpoint. If we have alerts going off and shutting down things because of some kind of a warning, if the data underneath it has been manipulated, it's going to be hard to trust that and do the right thing. This visual is from a risk management actually scenario with Neo4j and financial, but I think it shows how graphs can bring together data in various different silos so that we can then track ripple effects. So if something's changed, so this is classic data lineage, which doesn't sound sexy, but if you can't tell if a data point has been manipulated, and even if you know it's been manipulated, you can't tell what the ripple effect is, you can't trust your systems. And when I think about the scenario in a little bit of an expanded form, imagine that in something like a voting scenario. And that's something that's coming out for us all in the US very soon. We want to be able to trust this underlying data. Graph and data lineage is just a really easy way to do that. Another area that I think goes to fairness, and this goes back to the bias in data itself, in understanding our data. This Compass software that I mentioned briefly earlier is still used in the US and Canada, and it still does risk assessment scores. I threw up a couple visuals of some comparisons that were done in a report called To Predict and Serve, where they were looking at different risk scores based on the Compass software. Just one example, Vernon Prater here on the upper left had a really low score. Brescia had a high score, where they had both had committed an offense. Vernon had done some shoplifting in Home Depot. Brescia had borrowed her neighbor's bicycle, and they were given very different scores. Interestingly enough, Vernon actually had committed prior offenses of that same nature. He went on to then commit armed larceny. And Brescia never recommitted again. She only had a few misdemeanors in her younger days as a juvenile. Never reoffended. And the Compass software has been shown, as you can see down below, that it tends to underestimate the recidivism for Caucasian white offenders and overestimate the recidivism for African Americans. And so this has been shown to happen over and over again. The Compass software is the software I was talking about when it was deemed to be proprietary to show the logic of how things happen. The assumption is that demographic information, what zip code you live in, what kind of gang activity might be going on in your neighborhood may impact your scores. And the reason why this is important, not just from a fairness after you get convicted standpoint, but it's before. So these scores, in the case of Vernon and Brescia, these scores were given to them before they were actually convicted. So even when they come in and they have bookings, and this impacts and your whole experience through the system, whether you get parole or not, whether you get offered different programs instead of jail time. Your judge may see it ahead of time. Your lawyer may see the scores ahead of time. So the ripple effect of having this score could be quite significant. And being able to understand what data it was based on is, in my opinion, really very important. Graphs can help with that because we talked about knowing your data and data lineage, like what are the actual elements of the data. But there's also possible bias in how the data was collected, what we chose to train our models on. If you choose to train your model on zip code, that may not be a very fair way to train your model. So understanding what was used in the model, not just the data points, but how it was collected and how it was trained is very important. And graphs can help add this context so that when we do our machine learning, that we can understand the relationships of how the data was collected, when it was collected, and what it was used, what was the training features that we decided to choose as well, because that can really impact the outcome. So just a few examples there to show how graphs can add context and help with more responsible AI. But if we think about what's next, where are we going? I think most of us can kind of see how our human values are really going to impact AI in general. There's a couple examples where the European Union is putting out recommendations on how to have more explainable, unbiased guidelines. There was a call actually from the EU. Some people were actually thinking about banning facial recognition in public places in the EU. They walked that back. That didn't happen. But it just gives you an example of some of the things people are looking at. The head of Google actually was calling just recently, I think a couple weeks ago, for more AI regulation and to do it in a balanced way. And then even the White House asked NIST, the National Institute for Standards, asked them to look into how the government should engage for AI standards development. They've actually put out a plan. I would call it a plan for a plan. But these things are becoming influential to how AI is going to be developed. And the more we can trust AI, the faster we're going to have adoption as well within different markets and different uses. So the other area that I think is going to become standard is just context for AI. So we talked a lot about how AI needs context, how graphs can add context. We're seeing from a graph technology standpoint, we're seeing graphs being adopted in data science and machine learning first and foremost to improve predictions because they're very good for that and it's very much low-hanging fruit. But I think we're going to see that expand to having context. Whether it's using a graph or some other type of technology, it's just going to become standard for how we look at our AI and how we try to do better with AI in general. The third area that I think is really interesting, and those of you into technology will understand why it's exciting, is graph native learning. And so about a year ago, a little over a year ago, Google, as well as some other researchers, put out a paper of what are the current shortcomings in machine learning and how do we overcome them. And they walked away, and in their paper that you can look at, they walked away with this concept that graphs, because they have this ability to abstract and generalize structures, we're going to be the next big evolution in machine learning because they allow us to understand structures better and better than any one individual kind of neural net approach. And so that's a mouthful, and trying to kind of walk back of what that actually means. It's basically implementing machine learning inside of a graph data structure. And the idea is that you can start with a graph, and as we know, all our data is connected to something, and so it's naturally in a graphy format. And you can start with that format and have an output that's format, all while preserving your transient states. Why that's exciting? Two reasons. One is first, if you can preserve your transient state and you have a graph as a starting point and a graph as an endpoint, that allows your experts, your domain experts, to look at how decisions are made. And in deep learning in particular, we all know that it's very difficult to know how decisions were made, and being able to validate decision points and track back is a big part in the future to be able to understand how decisions are made and whether they can be explained. The other area that's really exciting, and the other thing that we get really excited about, is this idea of being more accurate with less data. And that sounds that it's much less data. That may not sound exciting on the front end, but if you can imagine doing things like whole graph learning, so that you're learning on the entire graph with multiple things at the same time, that allows us to do much more learning without having to go through as many iterations that we would normally do to go through a machine learning model. It may even help us understand what features, what we should be training on. So remember when I talked about even choosing your features is important. If you train a model to predict the perfect sock match, and you pick color as your main item, that's somewhat arbitrary. Are colors, having the same color sock, the best sock match? That is a choice that we would make, or maybe it's fabric, or maybe it's size, whatever it might be for an optimal pair of socks. But your choice of your features is also very important, and we believe this may help us bubble up significant features as well. And the whole idea here is that we're trying to go from a more rigid black box type of approach to something that is more accurate and more flexible and has more transparency. This type of technology isn't there today. There's nowhere you can go out and just buy some graph native learning off the shelf. It is in the research. Google's published a couple papers around this area. So I assume that they are actively looking and researching this. We're very excited about this. We're watching the space very carefully. We think it's the future of graphs and AI coming even closer together. So speaking to those of you who actually have hands-on keyboards, whether you're a coder or a data scientist, you have immense value right now. You have immense power in shaping how we go forward. And so I wanted to provide a couple tips for you guys so that you can do better in and be more responsible in what you're already working on. If you're in the planning stage and you're collecting data right now, first and foremost, know what's in your data. That is so important. You can use graphs to do that. Graph data lineage is something, like I said, doesn't sound sexy on the top, but it is so important. It's just foundational. I threw up a couple examples here that you can look, and these are going to be in the handout. So there's some videos you can look at Neo4j to kind of look at what that means, and then also doing things like debiasing your information, very important. IBM did a lot of support for the AI Fairness 360 toolkit, so that if you have information, know what's in it, and then try to debias it. Try to make sure that it represents um, the network that you're trying to predict for, that it's representative of population you're trying to predict for. The other thing is to just ask for help and to learn more. So as you're starting to do more work, look at places like the Algorithmic Justice League. They've got videos, tutorials. They have places you can ask for questions if you're not sure if you're being responsible about, or you could be more responsible with what you're doing in your machine learning or your AI area. The other thing that I can't stress enough is involve your domain experts. So one thing that I am disappointed actually in the software industry in general is the excitement over what we can do with predictions and AI, and believing that that means that all we have to do is throw more data and we're going to get better results at it. You might get more accurate results, but are the results that you get actually predictors of what you are trying to estimate? Is the data appropriate? What does success look like? What does failure look like? It's your domain experts that understand fraud, that understand insurance, that understand, your recommendations for different patient profiles. Those are the people that can really help you tune what you're doing. So don't leave those people out. If you're in the training phase, again, you can add graph to that. You can add relationships to be more predictive. Relationships are very predictive of behavior. So adding that in with graph feature engineering is a simple way to be more accurate. I actually threw up an example here again in the handout where they're looking at spammer detection, adding in different graphy type of features. You can also use graphs as a counterfactual. So if you believe you have a nice model, you can use graphs and knowledge graphs to search and say, can I prove myself wrong here? Is my model really completely accurate in what I should be predicting? The other thing you can do is look at model exchanges. So two examples here, Onyx and Max. What model exchanges help you do is have a way that is maybe not completely tested for your exact scenario, but have a way to have models that have some vetting. That if you're just Googling and grabbing a model from somewhere and going with it because it's easy to use, you may not know the underlying logic of that model and have any kind of vetting at all, or anybody looking at it. So just a way to get started with a little bit of a safety net, if you will. The other thing that I recommend is if you have an interpretable model, so maybe not something that's super sexy, maybe it's based on traditional statistics, but if there are interpretable models out there that perform just as well as a black box model, use it. It may not seem sexy if it's on statistics, but if you can interpret why a decision was made and it's just as accurate, there's really no reason not to use those kind of models. There's a researcher, Cynthia Rudin. I've got a little picture of her here. Again, links to some sessions that she's done recently this year that makes some of her work on interpretable models freely available at the Predictions Lab at Duke University. So finally, if you're actually at the point where you're looking at results and you're thinking about implementing your models, try to add context for the AI itself. You can add knowledge graphs. It's a common thing to do, to use knowledge graphs to have more speed and accuracy for heuristic AI. An example of that would be a chatbot for shopping. Let's say I am looking for I asked the chatbot for a bat for my husband's 50th birthday. It can add the context of who I am and my actual request to know that it doesn't need to send me to a zoological option. I'm not trying to buy a furry flying nocturnal animal, that I'm actually looking for a sporting good. And also because I said 50th birthday, perhaps it should not show me just any old bat. It should show me some more expensive, maybe special edition type of bat as well. So you can use knowledge graphs to make your heuristic AI better as well. The other thing is to use formal risk assessment and independent from the people actually building the tools. So there's a lot of different things you can do when you think about risk assessment. You could have a committee. There are companies that do that to review everything. I've talked to insurance companies that have committees that look at every potential risk when they are implementing a new model, including potential PR issues if something bad happens. Or you could do something simple like a checklist. And I would say there's no excuse to not doing at least a checklist if you're implementing new models. And if you don't know where to start with, here comes the EU again. They have some guidelines. They have they're formalizing their guidelines in February, but they already have a checklist of, I believe, around 85 questions that you can use internally and to just make sure you've thought about the different risks in your AI or your machine learning systems. The other thing is to insist on explanations in high stakes decisions. If you're predicting what flavor of chewing gum that I might like, I'm not as worried about how, the data that was based on and whether that's 100% accurate. If you're predicting whether I should get parole or what my insurance rates should be, I would say that's a high stake decision that we need to not just be accurate, we not just need to be 90% accurate because we could just predict everyone have a high rate, that we need to be faithful to what the model is trying to predict, and we need to be complete about our explanations as well. So we're not cherry picking our explanation and leaving out other indicating factors that were involved. So very important, especially for high stake decisions. So again, this is in the handout. You can look at some of these links. I think I may have added a few more links in the handout, but definitely there are practical things that you can do today to do better and to make our AI not just more accurate, but also more faithful to what we're trying to do and just overall more responsible as well. And so thinking about those things, I hope if you remember nothing else, that a lot of times what we're having angst at or the problems we're having in AI aren't really technical issues. They're actually human issues. And if we're not thinking about them from a human perspective, we're not going to really solve them with AI. We might get, something that is better to, a couple more decimal points, but that doesn't necessarily solve other problems that it may be bringing forth. So we have a question and answer time right now. And also just a quick note that the book that I co-authored on graph algorithms that does talk about graphs and machine learning towards the end is free until April 15th. And so you can download that at Neo4j. So with that, I'm going to look at some questions here and we'll get started on those.
Thanks, Amy. That was such an insightful presentation.
Okay.
And we do have some questions. The first one is, you mentioned graphs and context for more flexible AI. Can you give us an example?
Okay. Yeah, no, that's a great question. Yeah, good catch. So if we think about graphs and context for more responsible AI, if we can understand the context by which not only something was trained, but by how it's applied. So an example that comes to mind is a chatbot that was used, I believe it was in EMEA in Europe, where it didn't understand the difference between a 7-year-old speaking to it and a 47-year-old. It didn't take that context into view when it was having conversations. And graphs can help us kind of flex to say if the person, if you know their age, you should respond differently to them, but also take cues from the language that they're using, from the time of day that perhaps they're on the system, from maybe the location that their IP is, so that taking all those different things into context can help the AI adjust its response and hopefully be able to respond differently with different types of language and different types of users. So that's just one example.
Oh, great. Thank you. Another question, this is an interesting one. What's your stance on government regulation of AI?
Okay, that's a big question.
It is a big question.
So you might, yeah. So you might. It is, and I believe that we are seeing a collaboration start, which I think is appropriate, which is public-private, to look at regulations. I think the question is not whether we should do regulations, but what they're going to look at what they're going to look like, and who should have a voice in that. And I think we should all have a voice in that, both as citizens, but also as businesses and organizations that operate in this space. And we can see this collaboration start with things like the U.S. NIST organization looking for feedback on what kind of regulations there should be and how the government should approach regulations. We can see this in the call by the Google CEO to actually say we need regulations, but we have to be balanced about them. And so being balanced about them means understanding, all the different opinions. So I guess the stance is not so much whether we should have any or not. I think that ship has sailed. I think we will have them. It's a matter of what they look like. And I've had very interesting conversations with some thought leaders out there that are looking at things like having different guidelines depending on the types of decisions being made. So I talked a little bit about more explainability for high stake decisions. We could very much be looking at things of rating systems where we rate the implementation of AI in different scenarios as high, medium, low risk, or something else. So I don't know what the final answer is going to be. I think we're on this journey, and it behooves any of us that really cares about this to be involved and be part of that collaboration.
Excellent. Thank you. So I know we're running a little bit over time. So I'm going to throw out this one last question. And if we haven't gotten to the question that you asked, someone from Neo4j will follow up with
Okay.
you after the event. But here's one. My managers are sensitive to extra work and time, aren't they all? Do you have any suggestions on how to bring this topic up?
Oh gosh. All right. So not easy in all scenarios. But I think there's a couple different things you can do. One is definitely show them some of the guidelines and checklists. I think I mentioned and it's in the handout, which merely some people are saying they're having trouble seeing the handout. So if you don't see the handout, we'll make sure to email that as well. But there's I think a really nice, easy way to have that conversation is, hey, the EU is a little bit ahead of us. They're already coming up with these checklists. Hey, it's really simple to just look at these checklists, see which questions apply to us, and use those. Why not? It's an easy way to get started. I think the important thing with these conversations, especially with bosses worried about extra work and time, which I totally get, is to let them know that this is happening, that our responsibility is something that the marketplace is going to continue to pressure companies to be more responsible, and that there are ways to get started that aren't onerous. A checklist is not onerous. So there's just a good way to get started, and then you can tailor for whatever your needs are. So I think, Marilee, I think if I understand correctly, we need to wrap this up. So I really appreciate everyone's attention and detail, and we will definitely get the information.
All right. Thank you, everyone, for attending. Thank you, Amy, for your time and insight. Everyone, have a great day.
Thank you.